7-4. This one is a little more challenging and the notes are a little bit longer. So you need to buckle in, take some good notes, make sure you ask questions if you get stuck, if you don't understand what's going on. Okay, we'll see how this turns out. All right, for the review, I want you to do this. I want you to go through and work it and see if you actually understand. It says draw a right triangle. You should be able to do that, no problem. Label the triangle A, B, and C with C as the right angle. That's the important part. The other two, A and B, you can put wherever you want them. Draw the altitude to the hypotenuse, so you need to remember what altitudes are, and label it CD. And then you're going to name the two smaller right triangles that are formed. What's going to happen today is every triangle, every big right triangle is going to be split into two smaller right triangles. So you'll hear me talk about 3 triangles in every picture. So this would be a good exercise for you to figure out what in the world is going on with that. Okay? First theorem. The altitude to the hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original and to each other. So this is the picture that you should have drawn. Okay? And what this is saying is that all 3 triangles in this picture are similar to each other. Okay? And so you're going to see me draw 3 right triangles in most of our problems for this. Alright, something else that has to be popped up is a geometric mean. This is another type of average, if you will, because a mean is an average, but this is a geometric average. And it's got its uses in society and that sort of thing. Not very often, but it does happen. Okay, so here's how this works. They're going to give you 2 numbers, and you're going to take the geometric mean of them by putting them into proportion. So basically what happens is you multiply the 2 numbers together and then you take the square root. So for the example, it says the geometric mean of 6 and 24 is 12. So we put 6 over x and x over 24 so that when we cross multiply, it comes out x squared equals 144. And then you take the square root and you get 12. Okay? It's a geometric mean. It's nothing too crazy. It is what it is. Okay? So let's try a couple of these just to make sure. Geometric mean of 4 and 18. So you do 4 over x and then x over 18. You can also do x over 4 and 18 over x. It'll do the same thing. So then we cross multiply. Take 4 times 18, get 72. And then we take the square root of 72 and we get 6 root 2, which you could change into a decimal if you really needed to. Okay? Just another type of average to throw in here, but we're going to use this property when we do our problems today. Alright, geometric mean of 15 and 20. Let's flip it upside down this time. So we'll do x over 15 and then 20 over x. You just have to make sure the x's are across from each other, the numbers are across from each other. So then we cross multiply. And then you take the square root and you get x equals 10 root 3. Okay? It's a geometric mean. It's nothing too crazy. Alright, now we've got some corollaries and stuff, and we're going to read them. You can write them down if you wish, draw the pictures, whatever. And then I'm going to show you, when we get to the problems, how to actually do this without much thinking involved. Okay? So corollary 1 to the theorem, where the theorem said that the triangles were all similar. So corollary 1 says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So if you take 6 and 24 and you do the geometric mean, you get the length of the altitude, which is 12. That's what it says. Okay? So hang on to that thought for a little bit and then we'll come back. Alright, corollary number 2. The altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the adjacent hypotenuse segment and the length of the hypotenuse. That's a whole lot of jargon. So what this is saying is if you take the whole length of the hypotenuse and one of the pieces of the hypotenuse and do the geometric mean, you'll get the leg closest to that piece. Okay? Same thing over here. If I do the whole hypotenuse and the piece and do the geometric mean, I get this. Okay? There is a way around this because this is really confusing right now, but there's a way around this. Okay? Okay, everything is going to be proportions, cross multiply, that kind of stuff. Okay, so in this picture, there are three right triangles. Okay, two of them that are kind of smaller, and then one bigger one. So I'm going to draw three right triangles. So you notice I drew them all facing the same way. They have to all be drawn facing the same way. Okay, so we're going to go through and label these right triangles from the picture. So the smallest one, I'm going to use this one on the left, okay? I'll call it triangle number 1 and triangle number 2. So this is number 1, this is number 2, and then the big one will be number 3. Okay? Triangle number 1 has x as the hypotenuse, it has y as the height, it has 4 as the base. Okay? Triangle number 2, you have to rotate to where it is standing up in order for it to match. It has y on the base and 5 on the height and nothing on the hypotenuse. And then the overall triangle, you have to rotate and then flip it so that it faces the same way. X is the base and 9 is the hypotenuse. Okay? If you're not sure about where these numbers are coming from, you need to ask me in class. Okay? So then we look at these and we figure out a proportion we can do to solve it. So I'm looking at the y's. There's 4 and y and 5. So we can do y over 5 equals 4 over y to solve for y. So we cross multiply, we get this. Now we have to take the square root because it's a square. And when you do that, you get 2 square root 5. So everywhere there's a y, there's a 2 root 5, just in case we need it. Okay, now we need to find x. So then if you look on the small triangle, it's got an x on the hypotenuse, a 4 on the base. The big triangle has a 9 on the hypotenuse, an x on the base. So we can do x over 9 equals 4 over x. Cross multiply, take the square root. Okay, if you redraw the triangles, it is much easier to do than trying to follow the corollaries. Okay, let's do another one. Alright, there's 3 triangles. Triangle number 1, triangle number 2, big triangle's number 3. So for triangle number 1, the base is 4, the height is y, the hypotenuse is x. And if you have to turn your paper and that sort of thing, by all means do it. Triangle number 2, it has a base of y and a height of 12. And the more you do these, the better you will get. It will just happen. And then the big triangle, base of x and a hypotenuse of 16. Now you have to come up with proportions. For x, I can look at, I've got x and 4 and 16 and x. They basically set themselves up if you have them drawn right. Okay? Cross multiply, take the square root because we have a square. We've got x equals 8. Okay, let's get a different color. Then for y, I've got 4 and y and 12. So 4 over y equals y over 12. Cross multiply. And then take the square root. And get 4 square root 3. Okay. So as long as you can redraw the triangles, this problem becomes easy because cross multiplying usually everybody can handle. Okay? Alright, I want you to see if you can do this one. Okay? Redraw the triangles and then set up your proportion. So pause this, and whenever you get ready to come back, you can check your answer. So pause until you have an answer here. Okay, you should have an answer of 20. If you got it, great. If you don't, see if you can figure out what you did. Okay? Same deal here. I want you to pause it, and when you think you've got the answer, you can come back and see what you've got. Okay? So for the answers, x is square root of 5, and then y is 2, and z is 2 root 5. I take that back. No, that's right. Okay. I'm going to leave this one completely. I'm not going to give you the answers. So if you do this one on your own and you wish to see if you're correct, come to me and I'll see if I've got it right. Okay, this one is a little different, okay? Because now there's an x plus 2 in it. So I want to do one of these with you and see what happens. Okay? Because the math is a little bit different here. Alright, so I'm going to do triangle 1, triangle 2, and then big one, triangle 3. Okay? Triangle 1 has x on the base and x plus 2 on the hypotenuse. Triangle 2 has a 5 on the height, nothing else. So it's pretty much worthless because it doesn't have any extra stuff. The big triangle has x plus 2 on the base and then x plus 5 on the hypotenuse because this whole thing is the hypotenuse. Okay? So then we've got our proportion. X plus 2 over x plus 5, and then x over x plus 2. You remember FOIL? You're going to FOIL on this problem, okay? So let me write out the cross multiply. Cross multiply goes x plus 2 times x plus 2, and then the other side is x times x plus 5. Okay, we're going to do some cross multiplying, and then we're going to do some FOILing, and then we're going to solve. So FOIL, you do first times first, and then first times last, and then last times first, and then last times last. Okay, over here, you distribute first times first, first times last. Okay, we've got some combined like terms that we could do. So we do x squared plus 4x plus 4. Now we got to work on some things. See how there's an x squared on both sides? So if you subtract x squared from both sides, what happens? They're gone. Because there's one on each side, they balance each other out. So now I can just subtract 4x over from 5x and get 1x. And get x equals 4. Okay? Not all problems that have x plus 2 and x plus 5 and that sort of thing in them are hard. So don't assume that they are. Okay? You do them the same way as anything else, just the algebra is different. Alright. This one's another one. I'm going to leave this one for you to try. Okay? Lots of examples. Maybe we'll go through them in class, maybe we won't. It depends on you guys. Okay? Same deal with this one. I'm going to leave this one for you guys to work on too. And this one goes back to the original stuff. Okay? So you've got a little bit of legwork here that I want you to do. I want you to go through those problems that I didn't work and see if you can get them, if you can get the right answers. If you can't, then let's go through and let's figure out what you can do. Okay? All right, good luck.